So in this section, we're going to learn how to identify or name points, lines, and planes. So the first thing we're going to see is what is a point. And a point is going to be a single dot. It's the simplest figure in geometry. You can name a point by a capital letter, and all geometric figures consist of points. Now, a point doesn't have any size. I know it looks like a dot, but it doesn't matter the size of the dot. A point doesn't have any size to it. So we've got a point here. It's indicated by a little dot, and then a capital letter. All of our figures will be made up of points. Everybody good? All right. Anybody still need it? Let's see what a line is. So a line is a geometric figure consisting of at least 2 points. It's extending in 2 directions without end. You can name a point, you can name a line by 2 points or a single lowercase letter. So down here at the bottom, you could either write out the word line and then the 2 points that are on it. You can draw a picture of a line on top of the capital letters, or you can indicate a line with a lowercase, and it's usually in italics. So again, what's important when we're naming a line is that we draw, if you're just going to use the naming convention with the symbol, is that you draw a picture of a line on top of the capital letters. A line continues forever without end. So you need to include the arrows on the ends. Okay, when we talk about a segment, it will not have the arrows. So this is how we can represent a line. Again, you can also write out the word. Good? Anybody still need it? Next we're going to talk about is a plane. And a plane, a geometric plane, could be suggested by a floor, a wall, a tabletop. A plane extends without end, just like a line. It has no thickness, like the point. Although it has no edges, it's generally going to be shown either as a rectangle or a parallelogram. So the red figure down here at the bottom is a parallelogram, and that's how you'll generally see a plane represented. It can also be represented as a rectangle. Okay, a plane can be named by a single capital letter or 3 or more points that are contained within that plane. So again, you'll be seeing them as pictures of either rectangles or parallelograms. Oops, so another way besides a capital letter or writing the word plane, you can also name a plane with 3 capital letters or 3 points that are located within this plane. So you could say that this is plane ABC. So you can name it by 3 points. Now, a lot of times when I'm talking about planes, I refer to the ceiling. You could think about the ceiling as being a plane. Just pretend like the ends of the edges of the ceiling go on forever. Or the walls. So again, the shape of my ceiling and my walls are rectangles. And just imagine that they never stopped, that they kept on going. So a lot of times when I'm talking about planes, I'll refer to the ceiling, the walls, the floors. I'll also get my tissue box or a box and show you how that could relate to a plane and their points of intersection. The next we're going to talk about is space, collinear, and coplanar. Space is the set of all points. Collinear points are all points on one line. So for example, I could draw a line and I could put 2 points on that line, A and B. And when the points are all on the same line, they are said to be collinear. Now, when I have points that are not on the same line, they're said to be non-collinear. So let's say I throw a third point here, and I label it down below the line. Then I could say points A, B, and C are non-collinear, because point C is not on that red line. And then coplanar means points that are all on the same plane. Non-coplanar means not on the same plane. So again, if I draw a parallelogram to represent my plane, and I draw 3 points on here, A, B, and C, these are coplanar points. But if I were to, say, draw a 4th point that maybe was above the plane, that would be a non-collinear point. So let's say it's on top, point D, and that would be a non-collinear point. It's not on the plane with those other 3 points. Pretty good? Intersections. So to intersect means to meet or cut through. So think about when you're out driving in the car with your parents, or maybe if you're driving now, where 2 roads cross. That is called an intersection. And generally you'll have a stoplight, 4-way stop. So where 2 things meet is an intersection. So where 2 lines meet, 2 planes, it's where they're going to meet or to cut through. So the intersection of 2 figures is going to be the set of points that are in both figures. Dashes in the diagram indicate the parts that are hidden from view. All right, line segments or segments. So we already talked about lines, and we know that lines go on forever indefinitely. However, segments, they're going to end. So segment AB is going to be written as the 2 capital letters, and then you're just going to draw a picture of a segment on top. No arrows. So the line, remember, had the arrows, but a segment is just going to be written like that. You don't have to show that it's got endpoints. You can just draw a dash on top. So when we're testing and using this throughout the year, it's going to be important that you use the appropriate pictures on top of your capital letters. So segment AB is written as AB with a line on top or a dash on top. It consists of points A and B and all the points in between A and B. All right, so it can also be, the order of this doesn't matter. So if I were talking about segment AB, I can also name it BA. And just make sure you have the picture of the segment on top. You know, if you want to write out the word segment, you can, and then put the capital letters, but it's a lot easier just to put that dash on top. Again, order isn't important for the segments. Order is also not important for lines. So again, a picture or an example of a segment, you would show a dot or a point at the end and a point on both ends, so A and B, and you could name this segment as either AB or BA, and that would be a segment. Again, remember the line would have arrows at the end. So know the difference between a line and a segment. Okay, next one. Okay, we're going to talk about rays. For rays, the order is important. So the first letter we read is the starting point, and then where it continues to would be the second letter. So ray AB would be written as capital A, capital B, with an arrow on top, which is the symbol for a ray. It starts at point A, the first letter, and continues unending in the direction of B. Now, if it were the other way around, then starting at B, and then the arrow is with the A, you write it as ray capital B, capital A. Again, you need to indicate the appropriate picture on top of the capital letters. When we are creating angles, angles are made up of rays, of two rays. So we're going to be using all of these basic things, points, lines, line segments, rays, to create all of the figures we're going to see throughout the year. So again, an angle will be created with two rays. The next slide talks about opposite rays. Opposite rays share an endpoint and point in opposite direction. So ray AB and BC are opposite rays. So AB goes in this direction, and BC goes in this direction. Notice they both start with B, and then they go in the direction of their endpoint. So these would be opposite rays. Together, these opposite rays form a line. The next slide. Okay, we're going to do some true-false here. Now, throughout the year, we will be doing true-false. We will also be doing questions that are called sometimes, always, and never. And those sometimes, always, and never questions, they're sort of like true-false on steroids. They're a little bit more challenging. But this is just basic true-false that we're going to answer these questions based on the definitions that we just learned about. So the first one, line PF ends at point P. Does a line end? No, right? So this would be false. Okay, remember a line goes forever. It's got those arrows on the ends. Point S is on an infinite number of lines. That is true. Now, technically, if I draw point S here and you start drawing some lines through it, you're thinking, oh, that's no way an infinite number. But remember, it can go out, in different dimensions. So it has an infinite number of lines that will go through that single point S, and that is true. A plane has no thickness, and that is true. Remember, a plane and a point, there's no size to it. Okay, like when I held that piece of paper up, you might think, oh, it's, super thin, but there's no thickness to a plane. Collinear points are coplanar. This one's true, but if we say it the other way around, coplanar points are collinear, then it's false. So let me draw a picture for you guys. So let's say I draw my plane, and if I draw some collinear points, so if I draw a line here, I have AB. If that line is in that plane, then those points are coplanar. However, the reverse would not be true. So if I had some points that were coplanar, let's say I have 3 points here, A, B, C. Notice they're in the same plane, but they're not collinear. So the reverse of this is false. So this would be false. They're not collinear, but this one is true. Planes have edges. Nope, they do not have edges. It's false. Remember, even though I'm talking about my ceiling, it looks like it's stopping on, where it's hitting the windows and stuff, but it goes forever. A plane does not have edges. 2 planes intersect in a line segment. That is false. Remember, planes go forever, so their intersection will go forever. So this should be a line. So segment is false, but if the statement said 2 planes intersect in a line, then it's true. 2 planes will always intersect at a line. Number 7, 2 intersecting lines meet in exactly 1 point. And that is true. So if you have 2 lines and they intersect, X marks the spot. So they always meet in 1 point. Number 8, points have no size. True. Line XY can be denoted as either XY with a picture of a line on top or YX. This is true. Okay? Order does not matter for the lines or the line segments. Also remember, you can name a line with a lowercase letter. So the order of the letters does not matter for lines or line segments. It matters for rays. Good so far? All right, now, the next slide, more true, false. Notice this time I'm giving you a picture. Now, sometimes in geometry, I'm going to give you pictures. Notice the previous slide didn't have a picture, and I had to draw some in there. So my recommendations to you is if I don't give you a picture, try to give yourself a rough draft. Try to sketch something out. I'm not grading you on your drawings, but sometimes if a picture is not provided, give yourself a figure. So let's go ahead. We've got a picture here. So it says, given planes M and N, use the diagram to classify if these statements are true or false. So point P is in plane M. Let's take a look where P is. P's down here. Is it in plane M? No. Which plane is it in? In. N. So this is false. It is not in plane M. Okay. B is a line. It's a lowercase letter. B is in M. True. Line XY contains point P. Is point P on that line? It's false. It's not on that line. Plane M, again, an uppercase letter, contains line YX. And it does. It goes through the side there, so this is true. Point A is on B, and B, it's a lowercase letter, so it's indicating that B is a line. Is point A on line B? Yes, it's true. And then number 6, points A and P are in plane M. Are both of those points in M? No. No, it's false. Which point is in plane M? A. Only A, yep. And then plane N contains point P? True. Pretty good? All right, now we're going to walk through some steps for drawing a figure. And again, I know everybody's not an artist, so you should always give it your best shot, okay? And if a picture is not provided, try and always draw in a rough sketch for yourself. So for A, it says to sketch a plane and a line that is in the plane. So again, you would draw your plane as either a rectangle or a parallelogram, and then just draw a line on top of that rectangle or parallelogram. Make sure you include the arrows to show that it is a line and not a line segment. Part B says to sketch a plane and a line that does not intersect the plane. So you would just draw a line outside of that parallelogram or rectangle. Now, I know you would think, okay, a plane's edges go forever, but think of, say, my iPad being a plane. And so if this is my plane and it's extending out forever, I could say that my pencil here is above this plane and it's not in it. So it's like on top of it. And then C, sketch a plane and a line that intersects the plane at a point. So just like I showed you before, when I had my pen go through the paper, that would be an example of a plane. And then if I were to put my pencil through my iPad, that would be a plane and a line intersecting at just one point. And I showed you that earlier with the paper. And again, you would show the dotted lines or the dashed lines to indicate the part of the line that you can't see. That's how you can sort of tell that it's going through. We have one more slide. And for this one, it wants us to sketch two planes that intersect in a line. And I showed you that when I cut the paper and how I slid them together. Now, it's easy to give you that visual with the paper. Sometimes drawing it's a little challenging. So again, you can draw your first vertical plane. So you could draw, say, a rectangle. You can color it in. And then you can draw the second plane. And then we could show like the dashed lines. So we could draw, do it with a pencil, go it here, back here, and then for the side that we can't see, we would indicate it with like a dash line. And then we can shade this. And it sort of gives us like a visual of a two-dimensional figure here. And again, the line of intersection is where the two lines or the two planes are meeting. And again, I did that with the two pieces of paper. I cut a slit in it and I slid the two pieces of paper together. So again, two planes intersect at a line, but a plane and a line are going to intersect at a point. So if you think about the classroom, think of the ceiling as a plane and the wall, and then up along the ceiling where they meet is a line. And again, remember, a plane has no edges, it goes on forever.